Today we are going to explain numericals based on electrolysis. Question number 3.13 of your exercise. Please read the question carefully. How much electricity in terms of Faraday is required to produce 20 gram copper, 20 gram calcium from CaCl2? This is the question. Now, already yesterday I have taught you Faraday's law, Faraday's first law and second law. But in chemistry, the problems which are given to you, all problems will be solved only based on the concept only. There is no need to use Faraday's law. Okay? Now see, how you solve this problem. What is the fact here? The charge on calcium is Ca2 plus 2 electrons. It gives Ca7. Now this is 1 mole. This is 2 mole. This is 1 mole. This 2 mole means what? 2 Faraday electricity is required. 2 mole electron is 2 Faraday. And 1 mole calcium is equal to 40 gram. Now the gram atomic mass of calcium is 40 gram. Since 40 gram calcium is obtained by 2 Faraday. Therefore, 20 gram calcium is obtained by 20 by 40 to 20 equals to 1 Faraday. It's very simple. And if one is asking how much Coulomb is required, you multiply by 96500 Coulomb, you can get. Now the same pattern questions are there. Now question number 3.15. Please look that. Question number 3.15. Read this question carefully. 3.15 of your NCERT. A solution of NiNO3 twice is electrolyzed between platinum electrodes using a current of 5 amperes for 20 minutes. What mass of Ni is deposited at the electrode? Actually in the question atomic mass of Ni is not given, but you see atomic mass of Ni you can check is equal to 59 U. 58.7, 59 U you can. Now how you will solve without using Faraday's law? Now Coulombs passed through the electrolyte. How much Coulomb is passed? So Q is equal to IT, you know already, is equal to 5. That T should be in second, so this is 20 minutes and this is 60. Its value will be what? 12, 5 is 60. This Coulomb, 6000 Coulomb. Okay? Now, write the equation. Ni2 plus aqueous plus 2 electron gives Ni solid. Now this is 1 mole, this is 2 mole, this is 1 mole. 2 mole is equal to 2 Faraday and this is equal to 59 gram. Okay. Now just use the unitary method, and this is nothing but 2 into 96500 Coulomb. You can use the unitary method since by just to multiply it. This is 0, 0, 5 to the 10, 0, 6 to the 12, this is 13, 1, 9 to the 18, 19. Check again, 0, 0, 5 to the 10, 1, 6 to the 12, 13, 1, 18, 9. Is right. But itna coulomb of electricity 59 gram Ni is deposited. Just check the unitary method only. Therefore, by 1 coulomb, 59 divided by 193,000 gram. Therefore, by 6,000 coulomb, 59 divided 193,000 into 6,000. Can cut this. Now this value will be, just for saving time I am using this, 59 into 6 divided 193. 1.834 gram Ni. The answer will be like this. So check the method. So any type of problem you can solve by simple unitary method and by simple application of this such type of equation. There is no need to use Faraday's first law, W is equal to ZIT, like that. No use of those formula. You can solve directly. Already yesterday I have given the homework based on numerical based on this topic of NCERT itself. And question number 2.16. Again, you can apply your brain and try to solve it. And 1 year in CBSE board there was a question. Okay, what is the thickness of the silver deposited on a given plate? What is the thickness of? How you calculate the thickness? Density of the metal or silver will be given. So you will calculate the amount of metal deposited. Now density is equal to mass by volume. On the basis of that, volume is equal to mass by density. Volume can be calculated. Length, breadth is given. So thickness will be, you can calculate by those methods. So try by yourself. These questions are very easy and these are very important for your board point of view. Now, I am going to explain the concept of batteries. This topic is batteries. This is commercial cell. In daily life, you use many batteries. So, the batteries, the principle of batteries, please listen carefully and try to make the note. The principle of batteries depend upon or based upon the formation of electrochemical cell. The formation of electrochemical cell with following criteria. So what is criteria? Criteria for a battery. Point number 2. Point number 1. This should be compact and portable. That should be compact and portable. Second, easy to handle. Point number 3, its potential should not vary very appreciably during its use. This is the main focusing point, because according to Nernst equation, as concentration of electrolyte changed, electrode potential will be changed. So in electrochemical cell, naturally the potential should be varied. But for a battery, the potential should not vary appreciably during its use. And the last point is, it should be rechargeable. If a battery is rechargeable, so this is said to be very good battery. These are the criteria for a battery. Now, we are going to write how many type of batteries are you knowing. How many type of battery you have to read. This is primary cell, you can tell. Battery or cell, you can write. This is secondary cell, and last one is fuel cell. These batteries you have to read. Primary is what? These are not rechargeable. Not rechargeable. This is only use and throw. This is all of two types. First is dry cell and second is Mercury cell. Mercury cell or button cell. Secondary battery is, these are rechargeable. Rechargeable. This is of two types. One is lead storage batteries, and this is Nicad cell. Nicad, nickel cadmium cell. These two battery secondary cell you have to read, and fuel cell only H2, O2 fuel cell you have to read. So, in this topic, we will explain about primary cell, dry cell, secondary cell, Mercury cell, and second one is secondary cell. This is lead storage battery. One is lead storage, and second one is nickel cell, and last one is fuel cell. Hydrogen oxygen fuel cell is popular for you. Now come to the first. See, it is dry cell, and this is nothing but the compact form of Electrolyte cell. Here, in brief, I have written. You should make the notes according to this way, so that it will be easy to learn. You can draw the figure from your book, there is no problem. But literature, this you have to write. What is anode here? Anode is cylindrical zinc container. Anode is cylindrical zinc container. Now, cathode. Cathode is graphite rod surrounded by powdered MnO2 and carbon. Powdered MnO2 and carbon. This is actually cathode is graphite rod which is surrounded by powdered MnO2 and carbon. Now, what is electrolyte here? Electrolyte is moist paste of, mind it, moist paste of NH4Cl, ammonium chloride, and ZnCl2, zinc chloride, which is filled between two electrodes, both the electrodes. And this is cylindrical zinc container. In the center there is a graphite rod, and this graphite rod is surrounded by this powdered MnO2 and carbon, and between zinc container and this graphite surrounded by MnO2 and carbon, this electrolyte is packed. Now, although the reaction of dry cell is complex, but according to this NCERT, in simple manner it has been given. Please look. Which type of reaction take place at a node? Look here. Zn solid is converted to Zn2 plus aqueous plus 2 electron. Cathode, MnO2 plus NH4 plus 1 electron become MnOOH plus NH3. Now look the oxidation state. Here the oxidation state of Mn is plus 4, and here the oxidation state of Mn is plus 3. It means there is reduction of Mn plus 4 to Mn plus 3. And sometimes students confuse, sir, what if cathode is graphite? Then there is no role of carbon here. That graphite is only acting as support. The reduction is of Mn take place. Mn4 plus is converted to Mn3 plus. Now Zn converted to Zn2 plus. Now the next part is always in every cell you have to write anode, you have to write cathode, you have to write electrolyte, you have to write the reactions, then cell potential, then use. Now, what is the cell potential? 1.5 volt. If you see, you have seen many type of dry cell. Some dry cells in physics lab you are having dry cell, very big dry cell you are having. The potential is given there also 1.5. In your torch, you are having dry cell little bit smaller. The potential is, cell potential is fixed 1.5. In your remote, you are using that dry cell and the potential is again 1.5. So, on the basis of the thickness or how the dry cell is big or small, the cell potential is not varying. This cell potential is always constant here. Now use. It has used in transistor, radio. Many students have not seen transistor nowadays, but transistor is audio system, transistor and clocks, wall clocks. So there it has been used. So 3 years back or 4 years back there was a question in CBSE board. Explain a battery which is used in transistor. Suppose you are not familiar with which battery is used in transistor. How can you reply the question? So this usage is very important. Now 2 type of question is raised from this dry cell. One question is, sir, in cell reaction, in cathode reaction you have seen, ammonia gas is released. Ammonia gas is released. And you have seen dry cell is compact and packed. There is no any hole in dry cell through which NH3 gas is leaked out. So, where this NH3 gas has gone? This is very good question. Or the second question teacher asked, you can write the question, what is the role of ZnCl2? Again I am repeating, what is the role of ZnCl2 in dry cell? You should write on your copy, what is the role of ZnCl2 in dry cell? Your answer is what? Your answer is, during cell reaction of dry cell, ammonia gas is released and the Zn2 plus of ZnCl2 combine with NH3 to form the complex. And that complex is ZnNH3 whole 4 whole 2 plus. Complex compound, you are having a chapter in inorganic chemistry. Later on we will discuss in detail about complex compounds. So this is the role of ZnCl2 in dry cell. Now next question is, again listen carefully, I am giving the language only. Please write, why dry cell become dead after some time, even not it is used? I am repeating the question. Why dry cell become dead after some time, even not it is in use? मतलब ड्राई सेल बहुत लंबे समय के बाद अपने आप खत्म हो जाता है जबकि इसका यूज आप नहीं किए हैं. Why it is? Very simple answer is, your answer is, sir, NH4Cl. NH4Cl is used here. NH4Cl ammonium chloride. It is the salt of strong acid and weak base. So NH4Cl is acidic in nature, which corrodes the zinc container, and hence dry cell become dead after some time, even not it is used. Okay, now we are going to explain the next cell. Now mercury cell or button cell. Look here, already you have seen the mercury cell or button cell. In wristwatch, all students are using the wristwatch. You have seen there is very small type of battery which seems like button. So it is also known as button cell. Now what is anode here? Zinc mercury amalgam. This is anode. Cathode is paste of HGO and carbon. Electrolyte is paste of KOH and ZNO. You have to learn it. Now come to the reaction. At anode, ZnHg plus 2OH minus gives ZNO solid plus H2O plus 2 electron. So write the reaction on your copy. Now cathode, HGO solid plus H2O plus 2 electron gives Hg liquid plus 2OH minus. Now this is overall cell reaction. Please add anode reaction and cathode reaction. What we get? Now this is 2 electron, this is 2 electron, it is cancelled out. 2H minus, 2H minus, it is cancelled out. H2O, H2O is cancelled out. So what is the overall cell reaction? ZnHg plus HgO solid gives ZnO solid plus Hg liquid. Now the cell potential is 1.35 volt. Usage of this. Again, I am focusing here. You must be familiar with the use of any battery. Here usage is low current. It is used in low current devices like hearing aids or watches. Watches means wrist watches. Now, one very important question. Question is what? Why the cell potential of mercury cell remain constant during its life. Why it is constant? You see, according to Nernst equation, we know that when concentration of the ion or concentration of electrolyte is changed, the electrode potential is changed. In overall cell reaction, there is no any aqueous solution, there is no any metal ion. It is a ZnHg, HgO, this is solid, this is solid, this is solid, this is liquid only. So all are, there is no any metal ion. The answer is there is no metal ion in overall cell reaction of mercury cell whose concentration can be varied. And it is the reason that the cell potential of mercury cell is always constant throughout its life. It is not varying. Okay, now we are coming to the secondary cell. Okay, secondary batteries, those batteries which are rechargeable and can be used again and again are known as secondary cell or secondary batteries. In this topic, we have to write two type of batteries. One is lead storage batteries, which is very common and all of you are very familiar with this. It is used in automobiles, cars, buses, in your bikes and inverter. It is used. And the main thing is this lead storage battery have volt in the multiple of 2 volt. It means each cell potential in lead storage battery is of 2 volt. So you can prepare a lead storage battery of 2 volt, 4 volt, 6 volt, 10 volt, 12 volt, 24 volt, like that. It means you can prepare, you can manufacture the lead storage battery of the voltage of in the multiple of 2 volt. Now come to the detail. Now here, learn and write this all in your copy and you have to learn. After reopening the school, I will check that. Now here write anode. Anode is lead. Cathode, a grid of lead packed with lead dioxide, I mean PbO2. Electrolyte is 38% solution of H2SO4. Now reactions during use or discharge. Now look at a node. Pb solid converted to PbSO4. Pb solid plus SO4 2 minus aqueous gives PbSO4 solid plus 2 electron. Naturally, here oxidation state is 0 and here oxidation state is plus 2. So lead is oxidized to PbSO4. Now here in cathode reaction, look, PbO2 solid plus SO4 2 minus aqueous plus 4H plus aqueous plus 2 electron. Now here the oxidation state of Pb is plus 4 and it is converted to PbSO4 solid plus 2H2 liquid. Here oxidation state is plus 2. Now add both the reaction. Overall cell reaction is Pb solid plus PbO2 solid plus 2SO4 2 minus and 4H plus, you can add 2H2SO4 aqueous gives 2 PbSO4 plus 2H2O liquid. This is overall cell reaction of lead storage battery when it is in use, when it is discharged. Now the cell potential of each cell, already I have told it is 2 volt. So we can prepare battery of 4 volt, 6 volt, 10 volt, 12 volt, 24 volt, whatever as our requirement by connecting them in series. Now usage of this battery, automobile and inverter. Again I am focusing use because 3 years back there was a question by CBSE board, explain the construction and function of a battery which is used in inverter. So this. Now after the use of this lead storage battery, here in the cell reaction you are looking that this H2SO4 is consumed. So a situations come when the concentration of this H2SO4 is decreased. After a certain limit, the lead storage battery needs recharging. The lead storage battery needs recharging. So during recharging of lead storage battery, so recharging, can write recharging. Here battery is connected by the source of electricity and it act as electrolytic cell. Now see, question is under what condition the recharging is required? Your answer is if the concentration of H2SO4 is decreased up to certain limit, the recharging of battery is required. For recharging of battery, it is connected by the source of electricity, and under that condition, if electricity is passed, there is a chemical change. So under that condition, the electrochemical cell, which is lead storage battery, act as electrolytic cell, and cell reactions are just opposite of the reaction during discharging. Means the electrode where oxidation takes place, in that you have to write this thing in left and this thing in right. Here this is in left and this is in right. So overall cell reaction will be what? I am just for your help, I am going to write overall cell reaction only. 2 PbSO4 solid plus 2 H2O liquid gives Pb solid plus PbO2 solid plus 2 H2SO4 aqueous. So mind it, in examination, teacher may ask, write the reaction of lead storage battery during discharge or during recharge. During recharging of lead storage battery, this reaction is just opposite of the reaction which is during discharge. Now, what beauty we are observing here? We are observing that during discharge of lead storage battery, the H2SO4 which was consumed, it is recovered, regenerated, and which is used again and again. Now, one very beautiful question is here. Why such type of recharging and discharging is possible in lead storage battery? Your answer is the formed PbSO4 or PbO2. The formed PbSO4 stick over the electrode. In both the reaction, PbSO4 is formed, and that PbSO4 stick over the electrodes. And so, this recharging and discharging is possible in lead storage battery. Now, the last topic is very simple one, and that one is Nicad cell. Now, the second type of secondary cell is nickel cadmium storage cell or Nicad cell. Here, please look, anode, this is cadmium, cathode, a metal grade containing NiO2, electrolyte, KOH aqueous. Reactions, look, anode, Cd solid plus 2H minus gives CdOH twice, solid plus 2 electron. Cathode, NiO2 solid plus 2H2O liquid plus 2 electron gives NiOH solid plus 2H minus. Now you can write overall cell reaction, add both the reaction. What you get? This OH minus, OH minus. We cancel out, electron, electron will be cancel out. So it will be Cd solid plus NiO2 solid plus 2H2O liquid gives CdOH whole twice solid plus Ni whole twice solid. Now the cell potential is 1.4 volt. Uses. This is used in cordless appliances like phone, pagers, mobiles, etc. One beauty is here that it is sealed. It is sealed. It is more costly than lead storage battery, but it has longer life. So today it is all about this battery. Only one lecture is required here. In next lecture I will explain about the fuel cell and corrosion and prevention from rusting or prevention from corrosion. That was the last lecture. For today, the assignments are, write the homework for today. The homework for today is in previous lecture I have given homework numerical based on Faraday's law. So here I solve 5 more numericals based on electrolysis from side book. This is one. And second, learn all the taught batteries. I will ask. Now today it is enough. So in next class we will discuss the next topic. Thank you.